Hello everybody and welcome back to my channel. Today's video is another step in the making of my metal lathe, and specifically today is about the spindle. The last time I finished the bed and the headstock holder, the base of the headstock. But before to continue, I had to return to the bed. I have removed the ways and scraped the surface to make it really flat. Then I reinstalled the ways and scraped the top of the surface to make it flat. So let's talk about the spindle. It is made of a bunch of components that I designed myself and ordered to a machine shop that made it bespoke for me. Then I finished the components, and here, after having made the holes and tapping the holes for the stop screw on the flanges, I'm gonna make the pits that will be used to tighten the flange with a wrench. And of course, since such a kind of wrench doesn't exist, I had to make the wrench for tightening the flanges. It was a source of headache because I designed parts for a tolerance, not interference fit, but transitional fit, to make it easier the final assembly. But I was afraid that it was too loose, but eventually it went out just 50 microns below the required diameter, and the ball bearings was installed with the retaining compound, and it worked perfectly. Another source of headache was the lubrication system. At first I designed the part to be lubricated by an oil bath, but at first I put inside too much oil, and the oil was too thick, and it ended up to clog the ball bearings. So I cleaned up everything and started over again, and used a special grease for ball bearings that I injected inside, and it went pretty good. The spindle have two flanges, one here and one here, that keep the shaft in place inside the barrel, and this flange is the lock flange, while this flange is the adjusting flange to adjust the preload of the ball bearings, to adjust the play of the shaft. Before assembling the spindle, I checked the static balance of the shaft. It is a job that requires calm and patience, not to mention the fact that it must be perfectly leveled. And this drawing shows how the spindle is assembled. Because I designed the parts with a transitional fit, one ball bearing needed to be pressed into the shaft with a press. But I was afraid there was an error, because on the other side it seems to be too much loose. But eventually it went out that it was only just 15 micron of less than the required diameter. That was resolved with with a compound, a retaining compound. This is not how it was supposed to be. Yeah, I was afraid that was an error. Here the inner ring, that is a spacer, and I cleaned it up carefully the parts before applying the retaining compound that is not visible in the video, and here the outer shell that is inserted inside the barrel of the conical bearing, and I had to ask for the help of a soft hammer to because there was a little bit of interference fit with the end of the thread of the barrel. Here it is, and the flange, the front flange is screwed, is fastened on the barrel. The flanges have a gasket, an O-ring gasket, that prevent leakage of oil in the case of oil lubrication, and there's the set screws that will hold in place the flange once the installation is finished. And again, inside the barrel I laid the retaining compound to hold one of the bearing, the internal ball bearing, and here I had to be very careful not to touch the barrel with the open rollers of the roller conical bearing, and so I have to be really careful, and with the help of a hammer and mediated by a soft hammer and an aluminum hammer with some touch. The shaft entered here with the help of a bigger hammer and a piece of wood, of course. And the last, after a final check, a last hit, soft hit, and the shaft entered into the barrel of the spindle. Again, here the compound, the retaining compound, is not visible in the video, but it is laid on the shaft, and because the outer shell of the ball bearing is kept in place by the external, the outer ring that you will see soon, and the outer ring on the shell of the conical bearing, the conical roller bearing, and the conical roller bearing on the back flange that will hold all together in place. And here it is, the outer ring that acts as a separator between the two bearings. It is placed with the help of the compound, and here it is. This is the retaining compound. Finally, I filmed it in one place, and it is laid on the shaft only, and again, and the final conical bearing is placed on the shaft. This is a convenient way to assemble the parts, and this is the back flange with a gasket that is fastened on the barrel, and that will keep in place all together. And here with the wrench I'm testing the ability to adjust the pressure, the force, the preload. And this ring is to prevent the entries of contaminants from the back of the spindle when in operation, and it is held in place with the help of this silicone sealant, white sealant, that will be easy to remove in the case of maintenance. And here the nose is cleaned up before installing the nut, the front nut, that will form a labyrinth with a flange to prevent debris, to prevent the entries of debris when in operation. And it is fastened with the help of this tool that I've made, special tool to fasten the nut, the front nut, on the shaft. And here we go, a final test to see if everything works okay. And it works okay. And here we go, the spindle is assembled. Okay, the next step would be to make the bracket to install the motor on the headstock. It will be a temporary bracket for a temporary motor, because at first I thought to use this old Georgi Cobalt motor made in Germany, but aside that it missing the resolver, the brushless driver for this motor would cost more than a vector inverter and plus the induction motor. The ensemble would cost less than the single driver for this motor. So I'm sorry, but this motor will stay here. So I hope you liked the video, and if you liked it, please click like, and don't forget to leave a comment in the section below. Okay, that's all folks. Thanks for watching. Cheers from the Alps. See you next time. Bye. Forgot.